Hello everyone, I'm Frédéric and I'm the project lead for Eclipse ThreadX. I'm also helping out at the Open Hardware Foundation with programs, which means, well, I need to deal with chip designers who have no idea. Anyway, no, we need good chips to run good software, and essentially this poster is about part of that story when you take a look. So what happened is essentially this. Historically, we had some RISC-V ports for Eclipse ThreadX, but they weren't top-notch quality. So a friend from 10x Engineers, a member of Open Hardware Foundation, my friend Akif, contacted me and proposed that he would work, on improving the state of our RISC-V support. That was back in December 2025. So since then, we got hard at work, Akif worked, I worked, and finally we made meaningful progress. Now you will ask me, okay, but I have no idea what ThreadX is. Okay, so let's take a step back, and that's the top of this poster that explains to you what ThreadX is about. So the short version of the story is this. ThreadX is the only open source real-time operating system which is also certified for safety critical applications, which means you can use it in cars, in medical devices, on the next space shuttle, if they ever build one. Whatever you have in mind, ThreadX can do the job. And it can do this in a very, very small size. So if you turn off some specific features, you can make the ThreadX kernel as small as 2 kilobytes and comfortably fit the network stack and other features in 120 kilobytes or less. So that's quite impressive. Of course, ThreadX has been built from the ground up for very small size, but also for high speed. And in fact, it's known for sub-millisecond context switches, which is very, very important if you need to guarantee latency in a safety critical application. ThreadX has been around for a while, since 1997, and essentially for a very long time it's been a commercial product, sold under that name by a company called Express Logic. Microsoft purchased Express Logic, and then they renamed it Azure RTOS, and now ThreadX is back under its own name as open source at the Eclipse Foundation. But the one thing to remember about it is that it's been deployed in 12 billion devices to now and counting. And so that's a massive amount of devices running it. You probably have one of those in your own home right now. And what's fascinating is that that makes ThreadX the most widely adopted piece of software at the Eclipse Foundation, whether you want it or not. So no one comes close, to beat us. Okay, now in terms of RISC-V support, what did we do recently? So back in March, so I said Akif and I got to work in December. So back in March, we have a quarterly release of ThreadX because we are on a quarterly release cadence, and we had a number of improvements that are listed on the poster. So there were improvements to the 32-bit and 64-bit ports. There were also QEMU delivered, and even a CDAG or LLVM port contributed by Torres. And since then, we've had additional contributions like support for the vector extension on 64-bit systems. We've got support for specific CPU, which was contributed by Alibaba, so a CPU from their Shanti family. And then, of course, since nothing is serious unless you can procure some hardware, so my friend Akif had a Banana Pi board lying around, and he ported ThreadX to it to demonstrate that we can run on commodity hardware as well. So that was really fantastic. But that was then. Since then, we made this June release. As I said, there are a few features I already mentioned that were included there. But really, the focus of that June release was to restructure, refactor all of those contributions we've got from third parties and make a coherent whole of our RISC-V ports. And the future is looking bright. So for September, we are aiming already at improving the support and get support for the CV Wally, which is the core of a newly published textbook that will train the next wave of chip design engineers all over the world. And they will know, and they will start learning on CV Wally, so I need ThreadX to support that. And of course, we we have this contribution of a QEMU BSP, and we want to make that an integral part of our CI/CD for ThreadX, in the sense that when you will push a PR in the future, it will run our regression test suite in a normal x86 environment, but then it will run the same on our QEMU RISC-V environment to catch platform-specific bugs earlier in the release process. So if you submit a PR in the future and you don't care about RISC-V, you would care about it because we'll check you for compliance and, of course, for whether your code compiles on RISC-V or not. Now, what did we learn of all of that work specifically from a RISC-V perspective? And really, there are a few lessons there. First, automate. So the QEMU part is really important, because if you don't automate, then of course you won't be able to catch early those platform-specific bugs in your release process. And in this particular case, the regression setup helped us catch that there was a specific bit, the MPI bit, that was missing when we were doing our MS M status setup. So without that CI/CD setup on QEMU, we wouldn't have been able to catch up that particular bug. Of course, M status is a minefield. Every bit matters, so that is the corollary, of course, of the previous point. And in this particular case, using macros instead of hex codes is really important, because those macros tell you the intent of specific things that you're doing in the code, rather than having a random X number that you don't know exactly what it's used for. So those macros are really key. Of course, when you have IIC extensions, you need the full context save and restore for that. So you shouldn't be naive about, oh, I will just, save the standard set of registers. No, you need to do it, extensively and systematically in order not to lose information. And of course, then, since we wrote so many BSPs, the point of my refactor was to standardize the setup of those BSPs and make them more uniform and share code whenever it was needed in order to avoid duplication. So standardizing early in your BSP format is really important. And finally, don't have platform-specific assumptions in your platform-agnostic test harness. And for us at ThreadX, that's really important, because what we call ports, what it makes the adaptation on a specific platform possible for ThreadX is really just a handful of assembly files. All of the rest is portable C. So when I run my regression test suite, if there are platform-specific assumptions built in there, then of course they will break on a different platform. And RISC-V support, working on that, helped us surface a few of those assumptions that we needed to correct in tests. So for us, this has been very beneficial. And now we can say that ThreadX, of course, is a first-class real-time operating system for RISC-V, but we are not done. So I talked already about our upcoming September feature release for CVLE support, but then we have ambitious plans to deploy hypervisor extension support and to implement S-mode support as well. So that will really make it a first-class citizen in virtualized environments. So from that perspective, the future looks bright, and certainly, if I come back next year with a poster, probably I will have too many RISC-V things to fit on it, which means it will be completely illegible, but that doesn't matter. The important thing is that ThreadX as a project advances and follows the evolution of RISC-V.